Hi guys, this is for the study guide for Module 2 and transformations. So looking at number 1, we have translations using vectors. So for number 1, we have this pre-image. So remember the pre-image is before we go ahead and transform it. All right, so number 1, triangle RST is translated along a vector, okay, to create the image R prime S prime T prime. What are the coordinates of the vertices in the image? Well, let's look at R. So point R was at 2 comma 9, but our vector, if we see our vector here, our vector goes from wherever our pre-image was to our image. It goes down 1, 2, 3, 4. So our vector, okay, goes down 4. And it goes to the right 1, 2, 3. And that's how we write the vector. So this really just means 2 plus 3, right? So 2 plus 3 will be 5. 9 plus the negative 4 is a positive 5. So we can just apply the vector to every single point. So now next up on the table here is S, and S is at 6 comma 6. So we're going to apply the rule. So 3 plus the 6 is 9, and the 6 plus the negative 4 is the same as saying 6 minus 4, which is 2. So S prime is going to be at 9 comma 2. Next thing for t, do the same thing, apply the same vector. So we have t at 1 comma 6. So 1 minus or 1 plus the 3, that's 4, and 6 plus the negative 4, again, will give us 2. So those will be the new coordinates of our image. All right, I already answered the next part, name the vector. So again, we went to the right 3, down 4. Okay, notice how I just used the points, and that's very useful to try. Now write the rule for the transformation. So whatever our coordinate was, x comma y, the x, we add on 3, and our y moves down 4, or subtracted by 4. Okay, so that's the general rule for this translation. Okay, number 2, graph the image of the transformation given, and they give us this translation, okay? They say connect the pre-image, sorry, that's pre-image, point to its respective image point, all right? And then find the length between the 4 line segments. Okay, let's try that out. So first things first, we have point, let's see, QRS, PQRS. Okay, so we'll start with P. Our vector here for this translation can be written like this, to the left 1 and up 2. So for P, point P, let me change my pen color so something a little bit more visual here. P is going to go to the left 1, up 2, and that's where P prime will be. Q, again, same thing, to the left 1, up 2, and that'll be Q prime. Don't forget the prime notations. Okay, same thing with R, to the left 1, up 2, and that'll be for R prime. Again, I'm just applying the vector here, okay? All right, last but not least, S to S prime. So left 1, up 2, and there is S prime. Okay, I'll try to draw a straight line segment as best as I can. There we go. And now find the length between the 4 line segments. I'll tell you what, you can try, okay, so P to double P, if you were to find the length here. What's the distance here? So find the distance between P and P prime. So try to find the distance. Now, how do you find distance between 2 points? Use the distance formula, or if you want, you could use Pythagorean. So you could either use a squared plus b squared equals c squared, or the actual distance formula, b equals the square root of second x minus the first x squared plus the second y minus the first y squared. So use either one, practice your distance formula, and you're going to use that for both this part, and this part. Now I'll give you a hint. What do you know about the distance for all these points? Okay, think about it. Go ahead and use the distance formula for these 4. Okay, I went ahead and set it up. Just remember which point's which. Okay, so get your practice right there, work together, and just remember the distance formula. And again, once you get your answers, what did you notice about all 4 line segments? Okay. All right, finally, let's deal with some rotations. All right, so write the rules for the transformation below. Graph the image, given the transformation, write the coordinate points for each figure. Okay, so we're doing 180 degrees about the origin. So the rule for 180 degrees, okay, as you guys have discovered, the rule here is whatever coordinate you have, okay, your x comma y, it's going to turn into the opposite of whatever that x is. So if it's a positive 3, it's going to turn into a negative 3. And whatever your y is, it's going to be the opposite. So let's start with j. Okay, hij. It's not alphabetical, but I'll start with j. J is at -1 comma 4. So you're going to go ahead and do the rotation. What's the opposite, or I'm sorry, what's negative of a -1? Positive 1, right? Negative of a -1, positive 1. And what's a negative of a positive 4? A negative 4. And again, that would be for j prime. So 1, comma, -4. It's down here. And again, that's for j prime. All right, next up, I'll just do k. So I did j, now I'm on k. And -2, comma 1 is where that point is. And for k prime, we follow the same rule. So negative of a -2, positive 2, and negative of positive 1, -1. So you're at 2, comma, -1 for k prime. And I know you're like, wait, it's landing on h. No, don't worry, h is going to move too. So let's deal with h. So h is at 2, comma, -1. But now we're looking for h prime. Positive or negative of positive 2, -2, and negative of -1, positive 1. So h prime turns to -2, comma 1 right here on where k used to be. So that's going to be where h prime is. Okay, next thing's up, last point, point I. We're at 3, comma 2. Let's apply the rule for our image point. So what's negative of positive 3? -3. What's the negative of a positive 2? -2. So we're going to go to -3, comma 2, and that is for I. So we could try to draw our line segments here as perfectly as I can. There we go. That's not perfect, but there we go. Oh, nope. Okay. So basically we spun around, we rotated 100 degrees about the origin. Okay, so this was our point of rotation. Okay, number 4, rotation of 90 degrees, counterclockwise. So again, counterclockwise is this way, okay? Now what's the rule for rotation of 90 degrees? Well, let's figure this out. If we were to rotate, let's say W, for example, okay, if we were to rotate him, something has to flip, right? So if we remember the rule, we had wherever your x and y are, right? But they flip. And which one negates? The x. So you could always try this. This is going off of my memory. And if you always want to double check yourself, you can. Try w. W is at -4, right? -4 comma 0. Would this work? Try it. See if it'll work. Flip them, and then it becomes 0 comma 4. But 0 comma 4 is up here. That doesn't make sense. If you were to rotate counterclockwise, you'd be down here at 0 comma -4. So what makes more sense? The y comma -x or the -y comma +x? So let's try that idea. Notice how I'm using the points to actually determine my rule just in case. Because what if my rule's wrong, right? So that's what I'm saying is don't always just rely on the rules. You can mix them up in your head on accident. Learn how to use the points. So if we did that, that would be 0 comma -4. Let's try that same rule with the -y instead for the other points. So let's try v, -3 comma 1. Let's try it. So if we do this correctly, they flip, and whatever your y is, it negates. So now for v prime, apologies, I didn't write it here. V prime should be at -1 comma -3. Okay, so again, this should be w prime, and this should be v prime. Let's try the other couple points. We have x, and that is at -4 comma -3. And to x prime, looks like the rules are happening here. It looks like we picked the right rule. All right, so flip them, and your y negates. So negative of a -3 turns to a +3, and your x just turns into your new y. So let's go ahead and graph 3 comma -4. 3 comma -4. There we go. And again, that's for x prime. All right, so let's try u to u prime. Okay, it's all about u. All right, so u prime. There we go. Flip them. Don't forget to negate the -2, your former y, and that becomes a +2, and your x becomes your new y. So u prime will be at 2 comma -1. All right, so let's go ahead and draw our line segments here as best as I can on a touchpad. Oh, I cursed myself right there. There we go. Oh, I'm gonna try it. No, I keep swerving over to the touchpads. All right, so that'll be u prime. Okay, so if you notice, it looks like it rotated, spun backwards, right? So as long as it looks like it did something like that, you're good. But notice what I did here. Okay, originally I thought of the wrong rule. I checked it out with a point and it didn't make any sense. Okay, it's not supposed to be there. It's supposed to be over here. Okay, so maybe I messed up on the rule. So I made some slight changes. You can always do that to double check yourselves. Okay. All right, number 5. Okay, for problems number 4, if the points are all rotated 90 degrees, given the angle measurement, find the measurements of their image angles. You don't need a protractor to measure this. So first things first, remember rigid motion when I talked about it. If W here is 110 degrees, what is W prime's angle going to be? So talk to your friends, see what that's going to be. And same thing with X, okay? So do this as your turn, okay? Talk to your group and see what your general consensus is. Remember rigid motion. Rigid motion, okay? Look it up. Look at your notes. What does it preserve? Okay, so that's the hint. All right, number 6. What characteristics or transformations should you find for images that preserve rigid motion? All sides are the same length. That is considered distance, right? Yeah. So rigid motion preserves distance. That means line segments and sides of any object. Translations. Translations, yes. Translations should preserve, right? You have a spaceship and you launch it really fast this way, it should still look like the same spaceship and nothing should have changed on the spaceship. Otherwise, your spaceship probably got destroyed and blew up, right? So you definitely want to make sure that rigid motion is preserved. Rotation. Yes, definitely. Definitely. Okay. If you look at number 4, the objects stay the same. Reflections. You look in the mirror, everything should be just the way as it is in real life, right? You don't look in the mirror and see your face, and then you look in the mirror and then you see like super mega face, brah, with way bigger eyes. Okay, that doesn't happen. Okay, so reflection should preserve rigid motion. Okay, so again, this is the example of not, but yes, it does preserve rigid motion. All angles are the same measurement. Yes, definitely. Dilation, no. You have your little spaceship, and then something happens and it goes super big. Okay, that does not preserve rigid motion. Otherwise, your spaceship just blew up or something. Who knows? All right, image compresses. Okay, so let's say you go into your machine, your teleportation machine. That's a teleportation machine. And then you come out, and then you're just like, Honey, I Shrunk the Kids. No. Compression does not preserve rigid motion. Okay, look at the distance. It changed. Okay, was not preserved. Only one side has to be the same length. No, all the sides had to be the same length. See how your head is the same here on the teleportation example, but your height isn't? Something changed. Okay, it did not preserve rigid motion. Same thing with angles. No. Okay, all the angles had to be preserved. Image stretches. Well, you tell me if you're going into a teleportation machine. That's a teleportation machine. And all of a sudden you come out looking like one of those aliens from Fourth Encounter of the Third Kind. Those super big, huge, long, stretchy guys. Okay, that's no. You definitely don't want to stretch. Okay, next problem, number 7. Determining if the following statements are true or false about the figures below. All right, so figure 1 is figure 3 rotated around 180 degrees about the origin. Now look at the wording, it's kind of tricky. They're saying figure 1 is figure 3 rotated around 180 degrees. So starting at 3 and then rotating to become number 1. So notice the order there, okay? Is that true or is that false? Okay, 100 degrees around the origin. So talk to your group. That's considered a part of your turn. And see what your general consensus is with your group. Okay, and then also mention why. Okay, so try to do that with your buddies. All right, B. Figure 2 reflected across the y-axis is figure 1. So let's see, figure 2. I'm going to use a different color code here. I'll use green. All right, so figure 2 reflected over the y-axis is figure 1. So figure 2 is reflected over the y-axis and it's figure 1. Is that true? Okay, so is it? It went from here to here. What about the rule? Can you test the rules? Can you test them? Can you see if that would work? Okay, what's the rule here? What changed, your x or your y? Okay, so talk to your group. And also for the last one, by the way, or I'm sorry, for part A, definitely mention the rule as well. Okay. So again, part B is also a your turn. And I'll tell you what, to make things really interesting, these four are for you guys to do. Okay, for your turns. Try it today in class, work together, and see what you got. Definitely reference the rules. All right, next thing's up, reflection across the y-axis. So the rule for reflection across the y-axis is what? X comma y, right? And that's what you guys found a long time ago. And something changes. What does? Well, we know that j is on the y-axis itself, so it's just going to be hanging out there, all right? So j does become j prime. If you want to double check, we can always do that. But remember, we're reflecting across the y, so the x changes. Y stays the same. So if you apply it to j, you're at 0, 1. X changes. Well, what's negative 0? 0. And your y stays the same. So notice how j to j prime, you just map onto yourself perfectly. Okay, you just stay in the same spot, really. Now, k. Oh, that's not a k. Come on, you touch screen. Actually, it hasn't given me that many problems today. I'm actually pretty impressed. All right, k. Don't jinx it. Knock on wood. There we go. So k, 3 comma 2. And now we're going to k prime. What's the rule? X negates, y stays the same. So negative 3 comma 2, that's k prime. All right. Now, if you remember perpendicular bisector, right, you also know you could do that. If you're aware of perpendicular bisectors, it's something I taught. I know you guys did it. So perpendicular bisector, you'd also draw to L. Okay, same amount of space here from here. So you should reflect and be over here for L prime. You could double check with your rules and you should be okay. In the end, you should have something very, very pretty, like a butterfly looking like, or a plane, or spaceship looking like, mapping from image or pre-image to image. Okay, you could also double check the rules to see if it would work, just like I did using perpendicular bisectors. That's up to you. Me personally, use the rules. Okay, it's good to know perpendicular bisectors though. They did want you to write the new coordinate points, and that's another reason you should be aware to apply the actual rules, okay, to each and every point so you can see what's happening visually with the algebra. Okay, guys, so you will get a problem on your test, and it's something worth noting. Now, remember me talking about perpendicular bisectors. Okay, so that was one of our definitions. You will have a problem that may come up where they ask you to find certain values. In this situation, maybe they'll ask you to find, for one problem, they'll ask you to find the length of Jm. Okay, that's totally possible. Now, Jm is represented with an algebraic expression, 2x plus 4. But what do we know about Jm in relation to mk? Now, the definition of a perpendicular bisector is that, well, Jm equals mk. Okay, they are the same length, the same distance. Okay, so we use that for all our points when we reflect, right? So it's the same concept. So let's go ahead and use algebra to solve for Jm. All right, so I'm going to go ahead and use the symmetric property for the setup, just because I noticed that the 4x minus 6 is probably better to have on the left-hand side unless you want to deal with negatives, which is up to you. Now, mk is 4x minus 6, and Jm is 2x plus 4. Now remember the setup here, the reasoning that Jm is equal to mx is because of the definition of a perpendicular bisector. Okay, so don't forget that. It's very important to know. Now, this is substitution. That's how we were able to get the algebraic expression set up. Now, how do you get rid of a positive 2x on the right-hand side? By subtracting 1. Okay, so that's the subtraction property of equality. The 2x cancels out with the negative 2x. It's all equaling 4. And again, that was a subtraction property of equality. Let's go ahead and use the addition property of equality to get rid of the negative 6. 4 plus 6 is 10. And again, this was the addition property. Nice. Division property. So x equals 5. Now that's not what they were asking about. They were asking for Jm. Okay, so this was the division property, but do not box this answer. This answer needs to be substituted back into whatever Jm is. And Jm equals 2x plus 4. And we just said up here, x equals 5. So 2x is really just 2 times 5 plus 4. So Jm, oops, sorry, JW. For some reason, I felt like writing my initial. Silly. Jm is 2 times 5, that's 10, and 10 plus 4, 14. So Jm equals 14. Okay, so you might get a problem like that on your test. Definitely remember the definition of a perpendicular bisector and know how to set up the algebra. Now, there is going to be another similar problem based upon this situation, and that is the fact that perpendicular bisectors intersect the line of reflection at a 90-degree angle, or a right angle. That means they'll ask you to solve for y in this situation. Now, this is actually from your homework from your book. So to solve for y, we have to have, well, we have this given to us for this angle, right? We have the algebraic expression, algebraic expression of 3y minus 30 degrees. And that has to equal 90 degrees because this is, again, a perpendicular bisector. So we'll use the addition property of equality. And you're left with 3y equaling 90 plus 30, that's 120. Use the division property of equality, and you should get y equals 40. So remember two things. First, definition of perpendicular bisector means that this line segment is the same distance as this line segment, okay? And also that the angles here are always going to be right angles because they're perpendicular, okay? So knowing those two ideas, you'll be able to set up the algebra and solve for whatever they're asking. All right, thank you.